The concept of symmetry simplifies the design and use of any system. In our context, all indexer LPT commands universally apply to symmetrical groups of a small number of signals. Here's how. As it was mentioned in Part 1 of this series, standard parallel ports can be used to interact with control signals. Signals manipulated by the software generated from the computer are called outputs. Signals from sources outside the computer that are sensed by the software are called inputs. Indexer LPT software supports 8 outputs and 6 inputs on each parallel port connector. Indexer LPT references these signals in 2 electrically identical sets, so each set consists of 4 outputs and 3 inputs. The documentation calls a set of signals an axis. Since all indexer LPT commands apply universally the same to each axis, complexity is reduced to the consideration of only 4 outputs and 3 inputs. Indexer LPT supports hardware installations of up to 4 parallel ports, thus comprising 8 of these symmetrical sets of signals. However, one parallel port is typically dedicated to a control module, similar to the one shown in Part 5 of this series. The remaining ports, therefore, support up to 6 of these signal sets. The most common installation consists of 3 ports, where the onboard port is used for a control module, and a dual-port parallel interface card provides 2 ports, thus 4 sets of signals. Indexer LPT refers to each axis with a letter designator, A, B, C, D, E, F, G, or H. Groups of 2 axes are physically presented on each port connector, so one port may support axis A and B, another supports C and D, and so on. The signal set is called an axis because it is typically associated with a geometric axis of motion. Part 2 of this series demonstrated how 2 output signals, called step and direction, are used to control a step motor translator. The remaining 2 outputs in the set of 4 can be used for other things, which will be discussed in the next session. From the outside, each port connector looks the same. The computer distinguishes between each port connector by means of a port address. When you install Indexer LPT, an association is established between the port addresses and the Indexer LPT axis designators, as shown here in one of the diagnostic program's dialogues. Thus, for example, you could label one connector AB, another CD, and so on to easily identify the sets of signals that you are working with. Signal names identify the output pin within the set. As mentioned, the axis designator physically determines the applicable set of signals. So, for example, if the command move :A, 100 generates 100 pulses from pin 2 of the port you labeled AB, the command move :C, 100 would generate 100 pulses from pin 2 of the other connector labeled CD. More completely stated, the move command applied with the designator A manipulates the output pins entitled step and direction and monitors the limit switch input pins entitled low limit and high limit for the grouping under axis A. The move command can also be applied to other axes, B, C, D, and so on, in a similar manner. The application program, such as G-code controller, associates the signal set with nomenclature commonly understood in the industry for machine movement, such as X, Y, and Z. The document entitled Axis and Motion Nomenclature for Numerically Controlled Machines, available from the Electronic Industry Association as EIA-267B, describes standard nomenclature for different types of machines. Our demo machine, referred to in EIA-267B as a gantry profiler, consists of 2 linear stages situated at right angles and parallel to the floor plane. These stages are commonly referred to as X and Y. The third stage, vertical to the floor plane, is commonly referred to as Z. This G-code controller setup dialog shows how the signals for indexer LPT access set A can be assigned to control movement in the direction that G-code controller presents to the operator as X. Similar setup dialogs are used for stages Y and Z. To recap, since each indexer LPT signal set consists of only 4 outputs and 3 inputs, and each set behaves identically, the matter of dealing with inputs and outputs is greatly simplified. Input and output is the topic of the next session.